Hello. I'm from New Jersey, so I don't really know what time it is. It tells me it's 1:40, but I think it's a little bit earlier. My name is Michael Levan. Thank you so much for listening to me babble on for about, I think, 30 minutes or so. And I want to talk about platform engineering, but I don't know, call it whatever you want, right? It could be SRE, it could be platform engineering, it could be DevOps, it could be whatever you feel like calling it, all based on the title. I do everything from stuff like this to live training to engineering and consulting. For example, yesterday I was building out features. Today I am speaking. So I do a little bit of everything. And what I want to talk about primarily, and this is something that I'm really focused on right now, is the idea of distributed systems. What does that kind of mean? Pretty much everything that we do right now all falls under one of these categories in terms of pain points. So getting brownfield, getting new field environments up and running. This is probably one of my favorite ones where, maybe others don't enjoy, but I enjoy talking about this, where there are just a lot of tools right now. There are a lot of vendors. There are a lot of different ways to do a million different things. It's a hassle to have all these environments up and running and playing nice together, whether you're on the field of getting back on-prem or whether you're talking about what cloud you're going to be in or however you're thinking about it, whatever you're doing in your environment. One of these things always come into play here, whether it's the tools, whether it's the vendors that you're using, whether it's the open source tools or the enterprise tools, whatever it is, wherever you're running. And then it brings us to this point here, which is everyone needs to be an expert in everything. And it's not like it was 10, 15 years ago where there was one OIDC provider, right? It was pretty much Active Directory at that point, all for authentication, authorization. Now there are probably 50 plus. I don't know all of them off the top of my head, fortunately. But because of that, everyone needs to know everything. Everyone needs to know a little bit of everything. And that can obviously be cumbersome, right? There's no more just the Active Directory person or the Exchange person or the Linux admin person or whatever. Everybody needs to know a little bit of everything, which is awesome. But at the same time, it doesn't allow us to really get in depth with what we're doing. We all have to stay not high level, but hopefully everybody gets what I'm talking about, where it's you got to know a little bit of everything. And because of that, you don't get to do everything that you want to be doing from a in-depth perspective. The last two things here, no one's thinking about SDLC. Kubernetes is still, I don't even want to talk about that, right? I feel like everybody already knows this. But we're always on the bottom of the spectrum in terms of what we're focused on. How many times are we going to write IAC or HCL configurations? How many times are we going to write YAML? How many times are we going to manage clusters, right? For whether it's standard VMs just running your application stack or it's your Kubernetes environment or whatever. We're really focused on the bottom layers of everything. The servers, what do people say? Managing the pets, not cattle, whatever that saying is. That's how we're still thinking about infrastructure when really we should be thinking about it from an ephemeral perspective. One of the things that I talk about often is your clusters should be just as ephemeral as your containers. You should be thinking about your clusters from a blue-green perspective or a canary perspective, or just simply disposable. Your configurations, your application stacks, everything should be able to move with whatever environment you're in, whatever cluster you're in. And I think that's where platform engineering comes into play. When I first started thinking about platform engineering, this was probably like 2016, 2017. I forget what my title was at this point, maybe like infrastructure or something. And I was working for a small company, and they pretty much asked me, hey, we want to be able to do the AWS thing. The developers asked me, hey, we want to be able to do the AWS thing, but it's super cumbersome. There's a lot in the SDK. Like, we don't want to have to deal with all this. So I said, okay. I said, what I'll do is I'll wrap the SDK. I think I wrote it in Python at the time. I just created this CLI tool, and I wrapped the SDK, but I just exposed a couple of commands. That was it, just what they needed. And that was it. I didn't have to do anything else. And they were super happy with that. And I think that's where we could call that platform engineering. We could call it whatever we want. But the point is that you only need to know what you need to know. The only things that you need to know to do your job is there. You don't have to know a million and one different other things. So where does Kubernetes fit in here? Probably talk a lot about Kubernetes. I talk more about Kubernetes than I do anything else. And the reason why is because I'm a firm believer that because of the way the Kubernetes API works, has anybody here ever written an operator, CRDs, controllers, right? So what does that give? What did Kubernetes give us that nothing else has given us. We've always been able to programmatically hit stuff, right? What was it? The Power CLI module with PowerShell, right? We could hit ESXi boxes. We've always been able to programmatically hit things. That's not what Kubernetes gave us. What Kubernetes gave us was this idea of an extendable API, right? We can literally take Kubernetes and have it point to any API that currently exists and then manage it with Kubernetes. We're seeing that with Crossplane. We're seeing that with Cluster API and a couple of other different tools, right? And just anything that you want to build. So I'm a firm believer that Kubernetes should be the underlying platform. And it's not always going to be called Kubernetes. It's going to be something else. My assumption is we'll take the idea of the Kubernetes extendable API and we'll be able to run it anywhere. And we're seeing that already. GCP Cloud Run, if you're not familiar with that, they call it serverless Kubernetes, but it's actually Borg underneath the hood. So it's not Kubernetes at all. It's just an orchestrator. Azure Container Apps is Kubernetes underneath the hood, I believe. EKS with Fargate profiles, this whole idea of serverless Kubernetes. So I think what's going to happen is we're going to have the ability to take this API, call it whatever you want, run it anywhere. It's going to be a truly distributed system. This is my assumption of what's going to be next around the idea of Kubernetes. So when I'm thinking about building a stack, I'm thinking about it in three pieces: the interface, the platform capabilities, and the underlying platform. Maybe it's Kubernetes right now, but it could be whatever. It actually shouldn't matter. It could be bare metal boxes. It could be ESXi boxes. It could be Hyper-V boxes, whatever. The platform capabilities, what you can do on your platform. Maybe you want to run a little bit of GitOps. Maybe you want to do, hopefully you should be doing monitoring and observability. Maybe you want to do performance. Maybe you want to do something like Crossplane, whatever. And then the interface. Depending on what your role is, you could be the engineer building the thing. You're probably going to fall here as well. But then you're going to have people using your platform. So the interface is probably the most important piece. It could be the UI, it could be the CLI, it could be the API, it could be an IDP, whatever it is. How your users, your customers, your clients, your whoever are interacting with the platform is very important. And again, this brings us back to what I've been talking about, making distributed systems a little bit easier, but more importantly, not having to be an expert in everything. And again, full circle, this is what I'm hoping that platform engineering will give us. But again, call it whatever. I'm calling it platform engineering because that's the title of the talk, but feel free to call it whatever you want to call it. The idea is that somebody's always going to have to build the underlying platform. That is always going to be there. We're never going to get to a point where it's, yeah, you don't have to do anything, right? We kind of saw that with serverless when it first came out. It was like, yeah, just don't worry about infrastructure. And then everybody said, surprise, there's still infrastructure and networking here needed. So same thing, right? I'm not saying that. There's always going to be somebody. Like you work at Microsoft, you work at Amazon, you work at Google. Somebody's racking and stacking servers, all right? Somebody's building out the configurations for these servers. Somebody's building out the configurations for the virtualization environment. My question that I have to you, and this is, feel free to ponder this or not, should it be you? Should you be thinking about everything? Should you be thinking about, crap, I got to manage the cluster. I got to manage the VMs. I got to manage the API versions for Kubernetes. I got to do this and that. Or should you really be focused on the value-driven proposition for whatever you're doing, right? For whether it's the business that you're working for, whether it's the product that you're building, what should you really be focused on? And I think this is where SDLC comes into play. And I feel like it's not talked about it enough. Does anybody not know the SDLC process here? It's totally okay if you don't, obviously. Okay, so software development lifecycle. This is from idea to inception to build to deploy. It is you're sitting in a room and you're whiteboarding something, right? That's where the SDLC process starts. The SDLC process ends, it's deployed and people are using it. And that's really what we should be thinking about. There's no organization, unless you're a data center, right? Or unless you're working for a data center organization where it's like our value proposition is in writing all of this HCL and all this YAML and deploying all these environments, right? That's not where the value prop is. The value prop is my application deployed? Is it performing as expected? How does it look when it's deployed? Okay, so Kubernetes as the underlying platform. Again, I don't believe it will be Kubernetes for more than another, I'll say 5 to 7 years. I think it'll be something else at that point. It's going to be the idea of Kubernetes. I think the idea of Kubernetes is the next thing, this extendable API. but I don't think it's going to be Kubernetes. I think it's going to be a truly distributed system. It's not blockchain. I don't think it's going to be something like blockchain. I don't believe it'll be that, but it'll be very similar in the I can run it anywhere and it doesn't matter, like that concept. But yeah, I think that's what it'll be. And once we have that, we're going to have to secure it. We're going to have to create it. We're going to have to build it. We're going to have to monitor it. We're going to need authentication and authorization. And we're going to need a bunch of different pieces here to obviously make sure that this works properly. And I think these are all the pieces here. So we have our security, we have our scanning, we have our build, we have our monitoring, we have our management, right? This is going to be a big one, of course. I think if anything is going to get taken from Kubernetes, it's going to be this. Again, the idea of this extendable API, that's the thing that's going to get taken. Okay, so here we go. Platform capabilities. These are probably the 4 that I'm most excited about at the moment. And I don't think I'm going to have time to actually deploy and show, but I'll show a little bit of code. So cluster API, this is a way to create and manage Kubernetes with Kubernetes. What do I mean by that? You write some YAML configurations that look like a manifest because it is a manifest, and you deploy and manage your clusters with that. Kube Builder, this is just one way to utilize operators, which Kubernetes operators consist of custom resource definitions or CRDs and controllers. There's also the operator SDK, but I would say Kube Builder is probably the most popular one right now. KubeVirt, has anybody here played with KubeVirt? Yeah, all right, got I think one person. KubeVirt is awesome. I highly recommend playing with it. It's a way to run virtual machines on Kubernetes. Now, I'm not talking about like a container or a pod. I'm talking about they've actually built an operator to extend the Kubernetes API to have a new object, and this new object is a virtual machine. And you could take your existing VMs, copy those hard drives, put them into persistent volumes, and run them, or you could just run brand new virtual machines. It's pretty cool. And I know there's some talk about the going back on-prem thing or whatever, which we'll see if it happens for everybody. It's most likely not going to. But if it does, you have a way to still run Kubernetes with your virtual machines. And then Crossplane, which is the ability to create resources outside of Kubernetes with Kubernetes. For example, I can write a Kubernetes manifest that will create an S3 bucket in AWS or an Azure Virtual Network or something like that. With all these things, Cluster API, Kube Builder, KubeVirt, Crossplane, this allows us to pretty much do everything that we want to do and need to do with Kubernetes being the underlying platform. If all this stuff is done properly, you really don't need to go outside of Kubernetes to do much of anything. Aside from, there's built-in security, right? But you still need certain policies, monitoring and observability. But the core pieces of running your environment, running your application stack, everything can be done right with the Kubernetes API. And again, I think it's the 3rd time I'm saying it, so I won't say it anymore after this. I think that's why the idea of Kubernetes, that extendable API, will be the next thing. All right, where am I? Okay, then we have the idea of DevX, developer experience. And what is this? This is just making sure that whoever you're building for has an easy way to use what you're building. And again, this comes back to what we were talking about before of not everybody should be an expert in everything. It doesn't make any sense. Everybody should be able to focus on what they want to focus on, and everybody should be able to do what they want to do. DevX versus customer service. I get asked this question a fair amount. What's the difference? I think it's pretty much the same thing, to be honest. Anybody here in the product team, in their organization? Okay, got a couple of product folks. When you're building your product, right, what are you thinking about? You're thinking about who's going to be using it. You're thinking about the experience of the person that's using it. You're thinking about how you can better serve those people. So when we see the differences between customer service and developer experience, I pretty much put them in the same place. I don't think that they're any different. All right. And one more thing we'll talk about. Anybody use IDPs right now? Internal developer platforms or portals, or yeah, I think there are a couple of different ways to say that. When I say portal, people get mad at me because I don't say platform. So we'll just call it IDP for now. This is the place where, okay, so we talked about the distributed system, right? We built it from the bottom. We gave ourselves an easy way to build it. We did the capabilities, and then we did things like Cluster API and Crossplane to make everything in one location, and that one location being Kubernetes. but now we need to interact with it. And that's where an IDP can come into play. Again, I gave an example of an IDP before where I built out that command line tool for everybody to use, for the developers to use, but that's just one version of an IDP. It could pretty much be anything to make the lives of whoever's using your platform easier. All right, a couple of different tools. Port and Radius is an open source project out of Microsoft. Port, I would argue this is my favorite IDP. Has anybody here used Port? I don't work for Port, by the way. If you haven't used Port, check it out. It is a true button click for what you want to be able to do in your environment. So what do I mean by that? Let's say you want to give whoever the ability to create clusters, an AKS cluster or an EKS cluster or whatever. You just say, hey, here's a button, you click it, and your cluster is created. In the back end, it's probably like a GitHub action or a GitLab pipeline or a Jenkins pipeline or something like that, because you need a backend for it. Of course, the engineers are building that backend, but then you give everybody that needs to use it this button, because what have we been talking about this entire time? You should only have to do what you need to do, right? Not everybody needs to know how to build the thing that they're deploying. Okay, so I think that's about it. And I'll show three configurations here. Okay, so first, this is cluster API. So it takes a relatively long time to get up and running, so I'll just show the code. But the gist is, you install the binary, you have to initialize the management cluster. So when you initialize the management cluster, what that means is you have to put in the tenant ID, the client secret, everything to authenticate to Azure. And then you create a secret, Kubernetes secret, with all that authentication information. You create the identity, and then this part here is the most important. So once you put in all the configurations like region, Kubernetes version, how many nodes, etc., it spits out a Kubernetes manifest for you. And that Kubernetes manifest is what you use to just run a kubectl create -f or kubectl apply -f or whatever, and you get a cluster. So you're managing Kubernetes with Kubernetes. The second piece is crossplane. So again, same thing. You have a provider for crossplane. You have to create your own authentication, or not create your own authentication, but create like a service principal or something like that to authenticate. And then at the end, you have this YAML configuration here. And this YAML configuration, notice how it's creating a VNet in Azure. But I'm not using the Azure CLI. I'm not using Terraform. I'm not using anything. I'm literally using a Kubernetes manifest. So again, this just furthers along the proof of using Kubernetes for Kubernetes with Kubernetes and everything outside of Kubernetes that you need to do. And then last but not least is probably one of my favorite parts is KubeVirt. So with KubeVirt, notice here how it's an actual virtual machine object. This is not running as a container. This is not running as a pod, nothing. This is actually running as a virtual machine. And I won't go through all this YAML, but I'll point out a couple of pieces. Number one, the hard drive, right? Because it's not ephemeral. You need to be able to store all of the pieces of the operating system. And then you actually upload an ISO. Let's say you go on the Windows site and you download Windows Server or whatever version we're on at this point, or Ubuntu or whatever. You actually upload the ISO and then you run the ISO in Kubernetes, which is really cool. Yeah, that's it. Those are a couple of things that I'm working on right now that I'm really excited about. And I'm super pumped to get us in this idea that we don't have to know everything. We don't have to manage the underlying infrastructure as much as we do right now. We don't have to run a bunch of HCL code. We don't have to do a bunch of different configuration language stuff. I think we can get to the point where our underlying platform can truly be this. It should be as easy as a blue-green deployment. It should be as easy as a canary deployment. It should be as disposable as a container, right? Like containers got super popular because, well, for a bunch of reasons, but one of the primary reasons was because they're ephemeral. Like it doesn't matter. One pod goes away, a new one comes up. Your application should theoretically still be running as expected. And I think we can get the same thing with infrastructure. So thank you so much. Appreciate it.